if I turn that down and let's jack this up. Let's see if that helped the volume at all. Oh, good grief. Hey, now we got volume. Turn that off. Okay. All right. Okay, so now the volume's going to be garbage too. Huh? I guess I'm going to go back. I'm going to go back over this whole thing because you guys didn't hear me when I was telling what's going on. All right. The reason this live stream is on a cell phone is because my computer decided to take a dump. I can show you this here computer right there. Yep, that one. Right now, that computer is a $6,000 paperweight. Yay. So, that computer decided to take a dump, so my live stream, my entire live stream setup just kind of went belly up, I guess. Normally when I'm doing the live stream stuff, I have like a camera that watches the bench and actually watches what I'm doing. And I don't have that because now I have to use the phone. So I don't have $6,000 to fix the computer. And I was saying before that it is very easy. It is very easy to hyperfixate, especially for me. It is very easy to hyperfixate on the things that we cannot change, the things that we cannot fix. I'm sure we all have these moments around us where just life seems to be falling apart. And, whether it's like difficult to pay the bills, whatever. Well, that's one half of the mic I could be using. So whether it's just difficult to pay the bills that month or, God forbid, inflation be through the roof, either way, we all have those moments where life is just kind of tough. And for me, I know especially for me, and I feel like it probably applies to many others as well, it's really easy to hyperfixate on the things we cannot change. The things we cannot fix, right? Your car breaks down. You're like, I need a tune-up, or I need a thermostat, or I need new spark plugs, or air filter, or something. I mean, God forbid, a new engine. I just had a friend of mine that lost like his entire engine. He had never changed the timing belt. The timing belt stretched, the valves met pistons, and it went, eh! He needed a whole new engine for his car. And the car wasn't worth it. We've all had those moments, and it's really easy to hyperfixate on the things we can't change, especially for me. I have a bad habit of doing that. And I'll focus on the thing that I can't fix, whether I can't afford to or I don't have the talent to do it, which is rare, but it happens. Like this computer, for example. It's a USB bus. The USB, whatever the USB bus is, whatever chip on the motherboard is damaged. It says there's a short. I can't do anything about it. I'm not an electronics engineer, especially not to that level. I can't fix it. It's very easy in those moments for especially me to focus on the thing I can't fix. But in this instance, the entire reason that this live stream is on a cell phone right now is because I'm going to try and focus on the things I can work on. That's what I'm going to do. That's my let's get better effort. And nobody ever said that we can't do it. Nobody ever said we can't do it without a little extra help. So, cheers, everybody. That's where we're going with that. Anyways. All right, let me run you guys, if you'll have the patience with me, let me run you past what we're doing, what we're focusing on in this channel so far. So, this, as I was showing earlier, is a driver that I made. The entire point is I want to make a driver. It's not apple juice. What's up, Larry? Although I do call it my apple pie. It's a little creation I made with Angry Orchard and Fireball. Tastes like apple pie. Anyways. So, I need to control an AC current, right? The stuff that you plug into the wall, your wall outlet, that's AC voltage. That means it's alternating current is what AC stands for. I need to control that, whether it be a motor or a heater. I need to control that. So I'm building drivers to do that. This particular circuit is a driver that I built to do that, that uses MOSFETs. I'm not going to bore you with the details of why that's kind of unique. But it is, I'll just say that MOSFETs only work in one direction, so normally you wouldn't see those on an AC driver. But it was working. However, I blew it up. I was testing with the oscilloscope and forgot that the ground terminal on the oscilloscope is actually attached to earth ground, and I went doot, and it went poof, and it literally blew up the chips. Like, I don't know if you can see this, but that chip is literally split in half. Yeah, there you can kind of see it. Anyways, so yeah, I can see what the inside of a MOSFET looks like. So the thing is, it did work until I did something stupid. Now, my updated version, the thing that we actually worked on past live streams, what we developed and worked on, this was the result of a bunch of trial and error, a little bit of research, and with some trial and error there. This is a tunable zero cross detector, and that's this here portion of this chip right here where my finger's over is a zero cross detector. What does a zero cross detector mean? Well, AC current, like I said, is alternating current. That means it's going positive and then negative. You might be familiar with the sinusoidal pattern. Well, what that is that is a potential difference over time measurement. And what that means is that we're going positive and then negative and then positive and negative. So the current switches back and forth. That's why it's called alternating current. In order to control alternating current with a microcontroller or a computer, you need to be able to tell the computer when that 0 point is crossed. So alternating currents, doing the sinusoidal thing, and when it crosses 0, the computer needs to know that. And then there's a timer involved. This circuit, which was a raging success, by the way, this circuit allows me to tune that zero cross detection so that whatever element I'm working with, it's a combination of the switches. And yes, that's MOSFETs. MOSFETs have a time. MOSFETs, the optoisolators, the MOSFETs, optoisolators, and all the switches, they all have a time that it takes for them to turn on. So when you add all those up, you have, this thing takes time to do its job. The detector takes time to do its job. It then tells a microcontroller. The microcontroller takes a few microseconds to think about its job, and then it tells a couple other switches to do their job. Which means, and I measured on this circuit right here, I was measuring a 2 millisecond delay by the time it would sense the zero cross and actually turn on, which meant you only have about 8.25 milliseconds on a sinusoidal pattern to actually turn on. Of total on time, you only have 8.25 milliseconds. So because of that, 2 milliseconds represents a quarter of the time. So I could practically never get above 75% on a circuit like that. Well, this circuit allows me to lead the on time by more than 2 milliseconds. So I can lead the controller, and the way it works is it detects, it'll trip on its way down. So in other words, I'm getting too detailed. I'm sure you guys are getting bored. All that is to say, this allows me to force the microcontroller to actually think that everything is running exactly the way it should. I can tune it, and it switches, and then we hit dead nut 0, and that gives us 100% on time, which is good. Now I need to develop the circuit that actually does the switching, and that circuit is going to be MC32. That circuit is going to be a triac. So a triac is basically two diodes, two SCRs, silicone controlled rectifiers, whatever. It's two diodes with a switchable gate. They go back to back. You turn it on, and it can turn on alternating current. So a triac can turn on alternating current. It doesn't care which direction the current's moving in, it can still turn on. So, triac. So what I have here is I have a triac, and then I have an opto isolator. The point of the opto isolator is so that we don't blow up the microcontroller with 110 to 480 volts. Now, when I tried this circuit before, it wasn't really doing what I wanted it to. So what I figured I would do is compare this circuit to the one over here, and I noticed that I used a 4N25 opto isolator to trigger this circuit. If I'm not mistaken, a 4N25 opto isolator is not a triac. So I'm going to grab my iPad here. What are you guys up to tonight? Anybody doing anything fun tonight? I need to look up. Let's see. What is this? This is request for new circuit lab part. We don't need to be there. So I don't think my opto isolator was working right. Supposedly there's an opto isolator that only works on a zero potential voltage difference, which means it would only turn on at the 0 point, which is like kind of dumb because that puts you in a trailing off time. Is that kind of dumb? Turn on and then cut off. Actually, I guess I could kind of work with that. What is this thing? Oh, that's a light. I might could kind of work with that. Because I could let it turn on. No, that doesn't work. Because a triac requires a zero potential voltage. In other words, 0 volts between base and emitter. It requires 0 volts to turn off. So if the opto isolator doesn't turn on until 0 volts, that means I'm going to be on the whole pattern. And that is kind of what I was seeing. So I need to look up MOC 3021. 3021 data sheet. All data sheets. Let's see what that has to say. 6-pin random phase opto isolator triac driver output. That says random phase. That should not be a problem. Description: opto isolated triac drivers. These devices contain a infrared emitting diode and light activated silicon bilateral switch, which functions like a triac. They're designed for interfacing between electronic controls and power triacs to control resistive and inductive loads for 115. Yeah, that's exactly what it's supposed to do. I don't see any reason why this shouldn't work. Yeah, I don't. The reason I don't have any viewers. Shit. where are my other opto isolators? Let's see what else I have in the opto isolator department. All right, so the 4N25, I'm pretty sure is just a FET, not a FET, a transistor. So let's look at that. 4N, really? 4N25 data sheet. Yep, that is a transistor. That will not work. You know what? That kind of would work if I did. Would it though? Wait a second. If it needs a voltage to turn on, and maybe that's why they use capacitive drop circuits. Shoot. I could turn it on with a transistor. If I give the transistor, no, because the voltage applied to the gate needs to be relative to the pin A2 of the triac. So the voltages need to match in order for the gate to actually turn on. Right, so I have to have a triac-based opto isolator. Okay, that takes care of that. Let's try the MOC 3022. See if that, because I know some of these. You know what? No, let's try the MOC 3043. Some of these are 3043. Data sheet. MOC 3043. Data sheet. MOC 3043. Triac driver output opto. Oh, yep. Okay. So here's one. The 3043 is a zero cross triac driver. Device consists of a infrared emitter diode optically coupled to a monolithic silicon detector, performing the function of a zero voltage crossing bilateral triac driver. Now, what that means is that this won't turn on. They are designed for use with a triac in the interface of logic systems to equipment powered from 115-volt lines, such as teletypewriters, CRTs, solid-state relays, industrial controls, printers, motors, solenoids, and appliances. Okay, this zero voltage crossing to minimize conducted and radiated line noise. Simplifies logic control for 115-volt power. Yeah, this is definitely not what I want. So what all that means is that the MOC 3043, being a zero cross driver, automatically has a circuit in there. That means it won't switch on until it's already 0 volts. That means the sinusoidal zero potential voltage between pins A1 and A2. That does not work for us. We don't want that at all. So this, the one I have, the MOC 3021, should be the ticket. Now, I need to prove it is the deal. No. In order to prove that, I need to apply a pulse. How do I want to prove that? How was I doing this one? All right, so this one triggered, and we sent a trigger pulse here, right? So we sent a trigger pulse here. It would turn this on, power that. We got the rectifier here. I should save that, because that's a good rectifier, and I bridged it, so I can totally save that. No need to waste diodes. Hey, Kyle. I am drinking what I call an apple pie. It is Angry Orchard and Fireball. Tastes like apple pie. So let's see here. I do have a number of things going on that make this work, but how many of them are the trigger? None. None of them are the trigger. I have a resistor right there, and then I have a jumper right there. Yep, easy enough. Did I do the resistor? Maybe that's not enough of a resistor. And I call those Angry Balls. I like it. Angry Balls. Cheers, Kyle. Angry Balls. The balls are angry. All right. The trick is I need to turn this on with a controlled rate, which means I need a potentiometer input. I need to program the... Oh, no. Shoot. My computer's dead. I can't program. Son of a gun. I'm gonna have to find a way around that. Oh, doggers. Shucks. Life is fun. Life is very fun. You know what? I'm gonna do something else. Yep, changing gears. Can you guys see? You know what? I don't know if you can see. Let me turn the phone. Aha. Right there. See that thing? Right there. It is a coffee maker. And you're probably going to be like, what the hell are you doing with a coffee maker? I'm taking it apart. That's what I'm doing. So I have a mess. Oh, yep, I just did that. What I have is a mess. Officially. Because I just spilled the screws. All right, so this thing, right? This is a portion of a coffee maker burner pot that I'm trying to turn into a chemistry boiler. Like but I want to be able to control the temperature, like put a temperature sensor in there and like be like, hey, I want this to maintain 70 degrees. Do whatever you need to maintain 70 degrees. So, I guess electric Bunsen burner, whatever. But this thing is only like 150 watts. Let me take the resistance. And I was honestly getting kind of a little sad because 150 watts doesn't really do much. See if I can do it off the resistance. I think I did it off the resistance last time. Let's see if it works again. $145 ohms. 145 ohms divided by 120 is less than 1 amp. Yeah, so that's like 100 to 120. Chug that Fireball. Oh man, I just paid for that stuff. I can't afford another bottle. I have to cherish it. So that's like 120 watts for that burner plate. And maybe I should put that out of sight, just in case YouTube wants to be sensitive about it. All right. Maybe. Wait! Drunk. Let's take more than one drink. What's a burner plate? It's what I guess technically it's not a burner plate. Heater. That's I guess technically it's a heater element. Anyways, I'm thinking that one's only like 120 watts. This is not enough. But the one on the bottom here is bigger. So I want the one on the bottom here and see if it's more wattage. If it's more wattage, that'll make me feel better. I also don't know if these things actually have like inline heater elements in them, because I'm pretty sure wires. We got wires. Doop and doop. Knocking stuff over. Yeah, if the drink's too much, he might turn. You know, Electro Boom's not Indian, right? He's like, I don't know what he is. I think he might be Pakistani. What's a burner plate? Yeah. So, anyways, so this one is a little bit bigger, and I want to see if it's more wattage. Does he go full Punjabi? Never. Why? What's wrong with Punjabi? Hey, Punjab has great food. I don't care how you cut it. Paneer. They got good paneer poker and tandoori chicken. They got good food. Samosas. Love me some samosas. Okay. So if this is going to be more wattage, it's going to be less resistance. Nope. Same resistance. Dang it! Facts. Darn! That deserves another drink. Shucks. That really makes me wonder, though. Why is this one so much different? That really makes me wonder. Like, all right, let me tell you my thought. Let me tell you my thought process and why I even went to this. When you make a pot of coffee, I got coffee grinds everywhere. When you make a pot of coffee, normally, or I should say often, the machine is not heating the water as it rolls through. It's rolling the water through. You know what? I shouldn't say that, because not all the machines do that. Some of the machines actually do heat the water up and then pour it over, like especially those fancy coffees. But oftentimes with machines like this, they just run the water through and then heat the pot up. They're faster that way. But I guess I got to look for an inline water heater now. Maybe there's a water heater in here. So I was figuring, and the whole reason I even did this is I was figuring that the burner plate does such a great job of warming up coffee that it should work as a, I'm totally using the wrong tip on this, that it should work as, you know, a light duty boiler. I say light duty, like extreme light duty. We're not boiling water, but we can heat it up for sure. See, 1,000. Oh, there's some kind of heater element in here. This thing's got 1,670 watts. Hey, I just found stuff. What the hell is that? Make sure thermostat is off. Knob fully left until water has filled tank and come out of spray head. Oh, look at that. That's a spray head. Is that a pump? I think that's a pump. How about that? Oh, there is. There totally is. There is a boiler in here. I wonder how they get around a pressure vessel. I have no idea what I am doing. Oh man. I thought there'd be an easier way to undo that. Screwdriver. Yeah, this thing has way more in it than I thought it did. Stuff. Give me that. Now I need pliers. This is turning into a whole thing. This is going to be my next career path, fixing coffee makers. Gimme. Holy smokes, like, holy moly. That's like a whole thing. Why does that... No shit. Oh, that's how they're getting around the whole pressure vessel. It's not pressurized. That's how they're getting around it. Yes, sir. So they pump the water up. Come on, man. All right. There we go. So they pump the water into a tray, and then it gravity feeds into the boiler. And like this can legit be called a boiler. We got a hot water nozzle. Oh, this is crazy. There's a thermostat. Holy smokes. Ah, surely I can use this. There's a spray head. Now, how does it... Okay, so it pumps into here, right? Yes. Pumps up. That comes in. It pumps up into here. That pressurizes it into here. Right? Spray head. Wait, where's the... Well, now I'm kind of lost. Why? Yep. Now I'm officially kind of lost. This is some neat stuff, though. This is some very neat stuff. All right. Maybe I can use that for my boiler. Why not? Worst case, I got lots of nice little switches here. Okay. Well, oh, you know what? Maybe I should make this the okay. So that just turned into a lot more than I thought it was going to. Um, I was definitely wrong. I thought the heating of these things was taking place in the pot, and the these are just the warmers, the coffee pot warmers. These don't do dick. Huh. I'm a little, you know what, maybe I can modify it. I'm a little disappointed because I was hoping to use the coffee pot as like a little mini chemistry, container. And that's not going to work. That's definitely not going to work. Oh, yeah, Kyle. If you know so much, then why didn't you say that ahead of time, huh? I'm joking. I know I'm an idiot. We'll just go with it. So I'm trying to think about how I can use this boiler. Because this thing's a legit boiler. I got to get this thing out. Maybe I should make a video. I can't make a video. I don't have a computer. I can't edit. I've got footage that needs to be edited. I can't edit. Surely I can keep up on this thing. Where's the right tip for this? Okay, before I get too carried away, I spilled some screws. Let me pick these up before that causes a bigger catastrophe. I just had like a legit decent live streaming thing set up too. I'm like, dang it. Oh, okay. I need to take off stuff. And I don't care about stuff, so we'll just go snippy, 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 snips. For that, we're going to go snippy, snips for this. Yep. And you know what? I can take this off. That is on there. I need a wrench. Wrench! Ver beast me wrench. Great. Can't find my wrench. Oh, here we go. Or Baco's spanner. Because now I'm British, apparently. No, it's not even big enough. You're killing me. Alright, we're going to go with the old school stuff. Antique pipe wrench. Ta-da! That's right, boy. I guarantee you this is just basic flare. Probably get in here on this one too. Maybe. Maybe not. Oh, oh. Yeah, buddy. Hell yeah. Okay, the pipe wrench is pretty cool. I like my pipe. Yo, check this out. Ha! He who's got the biggest wrench wins. Oh, that one's got some girth. That's what she said. Boy, I like my antique tools though. I do. I have here's something you won't see every day. This is something you absolutely. Oh! Oh, I got that mounted. Check this out. Camera shake, warning, trigger, warning. Check this out. That, see if I can get you a little closer. That, see that line? That is still full of mercury. Yep, still full of mercury. Because, you know, we like to play with mercury, right? Drinks. Oh, we're getting good now. Okay, that pipe's off. I need to take this pipe off. These are just 1/4-inch flares. That's all these are. That's not anything special. So the other thing I'm wondering is screwdriver. Let's see. This pipe goes back. I don't know if I want to. I need to decide. All right. I originally was going to put a bigger tip. Yep, here we go. Bigger tip. Because the tip wasn't big enough. All right. Tip here. Oh, it is so warm being here today. You know, for any of you guys that are actually ever wondering, iFixit toolkits are actually really cool. Hey, where's my beer? Join me, Tom. Hey, in fact, we got another one. What do I want to open it up with this time? Ta-da! There we go. Oh, meter's yelling at me. It's like, where's mine? Ah, yes. This is way much better than I have a lot of old tools too. But unfortunately, I love that statement, Tom. Oh man. So check it out, Tom. There was an event, not an event. I went to the supply house the other day. So I haven't been around that long. I don't claim that I've been around that long. Oh, I'm so sweaty. It's disgusting. But I've been doing air conditioning for like almost 25 years now. And so I was in the supply house the other day, right? And I started in the air conditioning field. My tool sold as well. Wrong tool, Kyle. It's not the wrong tool. It's the right tool. All the rest of the tools are the wrong tools. Anyways, so I was in the supply house the other day, right? And I started in the HVAC field just before the changeover to 410A came out. So R22 was still the main thing. R12 was still around like a decent amount. And so, you know, everybody was like, oh, R12's, you know, the expensive stuff. R22 was still mainstream. And they were just coming out with R410A. And when they came out with R410A, all the manufacturers and everybody was like, oh my God, we need new certifications. We don't want you to work on it unless you've gone to a class and been certified. So I went through all that. I walked to the supply house just the other day. One of the old farts behind the counter was talking about that certification, having to go through the 410A stuff. And I went, hey, that's not that old. I did that. And literally everybody else in the store looked at me as like, oh my God, you were around back then? And I instantly felt like the old guy that I always, like the old guy that I was always like, the old guy when I was younger. And I'm like, crap. Now I'm that guy. Whatever. Just anecdotal story. Yeah, so been around a little bit. I ain't been around that long, but long enough to get that circumstance in there. I thought you got selected for Porsche after UTI. I did, actually, interestingly enough, Kyle. I was given the opportunity to go to Porsche. In my infinite wisdom, I say with sarcasm because it's very short. I thought the bigger money was going to be in Mercedes-Benz. So I went to Mercedes-Benz up in Boston. And I found out that pretty much every Mercedes-Benz dealership you go to, except for two, Mercedes company only owns two dealerships in the entire United States: Manhattan and Los Angeles. Those are the only two dealerships that Mercedes actually owns. All the rest of them are franchised, and all the rest of the franchises treat the technicians as a dime a dozen. We could just get anybody we want. So, now that being said, the other Alex that was on the board, the student board, the other Alex, he did go to Porsche, and he ended up leaving Porsche. I don't exactly know why, but I know he ended up leaving Porsche as well. I probably, like, Ferrari and Porsche probably would have been the better of the choices, but yeah, I ended up crazy as it is, just because I have a much longer history with HVAC than I do with automotive. I ended up earning more money fixing the air conditioners at the Mercedes-Benz dealership I worked at than working on the cars, by like a good $5 an hour. So, so when IRC Ferrari was a one-time deal. Fucking Ferrari. Oh, if I recall, is that what you meant? If I recall, I know I did have I did not have an offer to go to Ferrari, but I know a couple people had told me that I could. I don't know, maybe they were blowing smoke up my rear end for all I know. For the Volvo, and never touched a single Volvo post-grad. Interestingly enough, actually, I like Volvo. That's an interesting thing to go for. I want to get my wife into a Volvo, because I know they have a pretty good reputation for longevity and reliability, but at the same time, I'm kind of disconnected from the Volvo world pretty significantly, so I'm not sure which one to put her in, but we'll see. All right, what am I doing? Shooting the shit. That's what I'm doing. Shit is good to shoot. Ended up JLR. Oh, yeah. UTI, the good old days of actually succeeding at things. Yup. Sometimes I wonder if I still hold the records over there for the amount of awards I got. Oh, that was the good days. Good old days. Oh, come on. I can't even hold a screwdriver straight. Whoever invented flathead screws should be drawn and quartered. I'll bet it was British. You know what? This can go over there. There's a screw right here. What do I do with my pliers? It'd be different if I had the right screw. How are you supposed to get this off? Maybe this is what holds it in. I'm just thinking, the reason I'm going after this thing right now is because I'm thinking that this is like a legit, like a boiler pot in here. Oh, sweet! We're getting somewhere. Yeah, buddy. Where's my pliers? Oh, you know what? The Baco spanner might just be good for this. So what I'm thinking I might be able to do is use this boiler for the same thing that I was going to use the glass pot for. It won't be glass, so it won't be nearly as much fun. Or maybe I can modify this thing to fit. Either way, make it work somehow. Alright, this is going to ruin this, but screw it. Okay, now I have wires. Now I really do need my pliers to make sure I unplug these wires correctly. Can't find them, lost them. Oh, there they are. Yep. 2. Wires. All right. Apparently there was still water in it. Okay, that's it for the wires. Now how about the thermostat? Ta-da! There's the thermostat bulb. Almost there! Ah! We have stuff. Wait a second. Is that a periphery heater? It is. It is. Look at that shit. That is kind of crazy. All right, here we go. I got a boiler. Ta-da! Ha! I am sweaty as balls. But I got my boiler. Ta-da! Ooh, there's stuff in there. Okay, now, all right, Tom. After UTI screwed me, oh fuck, a story too often told. I tried to start really? A coffee company? It was the recession. So I didn't get it off the ground, but I still have a couple of those bun machines in my garage. Well, now you know what the inside of them looks like. Oh man, to be fair, they're an amazing coffee machine. I mean, it's kind of hard to mess them up to go wrong. So, all right, I'm going to take a couple different measurements here, and we're going to see if we can do some wattage calculations. Now, resistive heaters are about the only thing that you can take resistance measurements on and calculate the wattage roughly that they're going to run. Because resistive heaters, the wattage doesn't change. It does change, but not a lot as they get hot, as they run. Whereas a motor has inductive values, so you almost have to take the wattage live. Ooh, that's 11 ohms. Calculator. I need a calculator. Oops, I dropped my fuzzy. Fuzzy Wuzzy was a bear. Fuzzy Wuzzy had no hair. Fuzzy Wuzzy wasn't Fuzzy Wuzzy. Here you go. Turn that off. Okay. And calculator. Because, you know, you're not going to have a calculator in your pocket when you get older. Yes, we are. Damn teachers. Okay, so 11 ohms. So 110, let's go with 120. 120 divided by 11 equals 10.9, so about 11 amps. 11 times 120, 1,320 watts. That is, let's see, divide that by 746. No, watts. Watts to BTUs is 341. So divide that by 341. 3.87 BTUs, almost 4 BTUs. That is much more significant. Like a lot more. That is awesome. That will definitely get the job done. And then some. What did I say the amperage is? 11? Ooh, I need to make sure that my stuff is up to that much. Holy moly, this wire is like 287. I'm not sure what that. Maybe that was just to raise efficiency. Yeah, this wire that looks like a heat. So this wire right here wraps around the whole surface. That looks more like a heat tape. That's 256 ohms. So that's like almost no wattage. All right, I'm going to go ahead and take this thing apart. So this genuinely looks like I would be able to use this as, if I could figure out how to make it a vacuum chamber, I would be able to use this. Is this silicone? Yep, it is. I would totally be able to use this as a, oh, there's a water coil in here too, so I could, realistically, I could just run hot water. Where's my backhoe spoon now? Let's see what's inside the boiler. Oh man, we're 7 minutes past an hour already. And I am dropping stuff. Wonder if I could figure out how to make this glass. Like how to drop this into a glass manifold. All right. Oh, come on. There we go. There we go. Ta-da! Whoa, Nelly. It's a wee bit dirty. And there's definitely still water in there. So I definitely got to clean that out. For shizzle. So that's just a stainless steel drum. And this component. Alright, so that just drops down in there. That's kind of useless. And then a heater element right down the middle. And then this here coil. So, So I can plug this. That's easy enough. Those are sort of insulated. I don't know if they're rated for vacuum, but they definitely seem insulated. And this hole, I could maybe tie. Maybe I could tie the port into that, because then that leaves this hole for the thermo temperature sensing. Got to have a temperature sensor. And that would actually leave two different methods to heat the wall, to heat the stuff. Oh, I could use this port to add fluid. Oh, fluid level. I need to be able to detect fluid level. Since I won't be able to see it, I need to be able to detect fluid level. Ah. Yes. I am sure we can make something work with this. I am sure of it. This extra tubing around the edge may not be sight glass up the side. Yes. Oh yeah, like a boiler sight glass, like one of those tubes that go up the side. That would, yeah, I mean, that would definitely get the job done, for sure. And then, let's see, what would I do? I could, I mean, shit, just drop the vacuum, add more fluid in. Or rather a tube, yeah. 100%. Actually, so something we do in the chiller world is you just get a round sight glass and you connect two tubes up, one to the bottom, one to the top of the reservoir, and then you can move that sight glass up and down to get your level. That's just a cheater way to do it. We use that to figure out oil level. Yeah, I think that's a welded fitting, so I could just, drop the vacuum, put that in there. I can use this port. Yeah, I could modify that tube. I can modify this tube to be the vacuum pool. Easy enough. I don't think this other tube would be much use. Other than, like, if I wanted to maybe auxiliary heat. But that doesn't really matter. Yeah, I could just weld on a 1/4-20 tap. Actually, these are already these are already quarter flare. That would be easy. So I can just blank this off. I don't have any use for this extra coil, so I can just cut that off. So cut off the extra coil, put a cap on here, pull the vacuum here, blank this off, and use this for thermocouple, and then use this for adding fluid to the fluid level. So yes, the sight glass thing, got to figure out how I want to put a sight glass in there. This might actually work really well. Yeah. And then I can control the input of this by having the thermocouple actually in the fluid. I'll bet you I could add a fluid level detection. I could. Capacitive. If I used a capacitive contact system, I could run a thing in there that had multiple contact points that would give me a generic clear acrylic tube like for PC water cooling. I mean, you can get glass too. That's probably fine. I gotta weld some bungs in the stainless steel. Sounds like some TIG work. Yes. I think this is a winner. I think this is what we're going to go with. So that will be my... I didn't even tell you guys what I'm doing with this thing. I plan on using this gadget to process or purify hydrogen peroxide. That in itself seems innocent enough. However, when you get hydrogen peroxide over 50%, you'll notice that the stuff you buy off the store shelf is only 8%. When you get hydrogen peroxide over 50%, it starts doing some fun stuff. And this all has to do with the catalyst turbine engine that I'm trying to build. It's all related. Yep. All right. So, what do I need? I need to cut that tube off. Do I want to cut that tube off? Let me think about this. Do I have any use for that tube? I really don't. I can, if I'm feeling frisky, develop a LED-based level, very basic, multi-layer fluid level indicator. That's, yeah, if I do it capacitive, then it shouldn't have a problem with conductivity, so that should be fine. And I can run that down the middle, along with the temperature sensor. Run that down the middle. Then as soon as I can't program. I gotta figure out how to program stuff. I definitely need some kind of computer. Wait, what turbine engine? Is that in the planning stage, or have you started building it? Tom, I have not started building it. All of the work that I've been doing on the live stream is a build-up to what I'm calling a catalyst turbine engine. That's an engine that uses a catalyst reaction. So instead of my brain wants to go all scientific, but that doesn't really help right now. Instead of the suck, squeeze, bang, blow of an internal combustion engine, we're going to use a catalyst. So, for example, what a catalyst is. If I take platinum reacts with hydrogen. So they use platinum in fuel cells because platinum reacts with the hydrogen and will cause it to recombine into oxygen. I'm sorry, not oxygen. So platinum is a catalyst for hydrogen. When hydrogen comes into contact with platinum, it releases energy, and recombines with oxygen into water. A catalyst is something that will cause a reaction in another element without actually using up its own element. The platinum does not deplete as it reacts with the hydrogen. So that's a catalyst. The catalytic converter in a car has platinum and rhodium and all the rest of the ioms and fun stuff because the elements of the catalyst react with the other elements in the exhaust. I'm being scientific and I lost viewers over it. That's all right. So the entire point of this engine is that instead of using a combustion process, we're going to use a catalyst process to be able to transfer the hydrocarbons and the whatever we put into it, hydrogen, methanol, alcohol, hydrocarbons, whatever we put into it. It'll be able to catalyze those elements into the hot expanding gases that you otherwise would have and blow those hot expanding gases into a turbine. The turbine will quite efficiently turn the hot expanding gases into rotary motion at a very high speed. Thrust. We don't want thrust in this case. Actually, we don't want thrust. What we want is rotary motion. The entire point of this is to produce not only produce an engine that runs significantly more efficient, at least I'm hoping, significantly more efficient than a regular combustion engine, because regular combustion engines only run like 30% efficient at best. All the rest of the energy that you get, so you get 30% of the energy that you put in from the hydrocarbons, you get out as mechanical motion. The other 70% goes out as heat. Radiator, tailpipe goes out as heat. The catalyst process, I'm hoping, will produce a much more efficient process of turning hot expanding gases into rotary motion, and that rotary motion being high speed, we can run a high frequency generator. Now, the whole point of the high frequency generator is that we can produce a lot of energy in a small package. So that's something that a lot of plasma physicists know. The higher frequency you get, I don't know if it's easier, but the higher frequency you get, the more manageable the energy production gets. For example, aircraft, they run at 400 hertz. So your outlet runs at 60 hertz, right? The reason your outlet runs at 60 hertz is because back in the day, and I'm sure still today, there's a lot of inductive motors, like clocks, that require the frequency to be consistent in order for the motor speed to be consistent. So clocks use a shaded pole motor to turn. That shaded pole, the speed of that shaded pole motor is affected by the frequency of the alternating current. So when you change the frequency, you change the time. And so back in the day, obviously, that's all they had for clocks. So 60 hertz in America that's how you made sure everything kept time. Nowadays, that is significantly less important. But at this point, everything, there's a whole nother story behind why we still need to maintain 60 hertz in grid power, mostly because everything absolutely has to run the exact same frequency or bad things happen. But aircraft use 400 hertz. At 400 hertz, the motor can be the same horsepower. Let's take a 5 horsepower motor, right? 5 horsepower, 60 hertz motor is going to be roughly 75 pounds and take up the size of this bench. A lot of the size of this bench. It's a big motor. But if I do it at 400 hertz, it's a significantly smaller motor. But it's still 5 horsepower. Not as much torque. So what they do in aircraft is they run at 400 hertz, and that motor then spins a lot faster because it's 400 hertz instead of 60 hertz. So it spins a lot faster. Still the same power and wattage of that motor, but it's spinning faster. So to increase the torque, we put a gearbox on the motor, so that now outputs the same torque as your 60 hertz motor, but the combination of the smaller motor and the gearbox is still half the weight of a normal 60 hertz motor. It's ridiculous. When you get even faster in frequencies, your manageability of the power, of the wattage that you're dealing with, just increases a lot, especially when the things that you were working with are designed to run at that high frequency. 400 hertz in aircraft is actually determined by the fact that an iron core transformer or an iron core motor, such as the rotor in a motor, it's laminated iron core. Once you exceed 400 hertz, that's the downside of higher frequency. Is your higher frequency induces higher eddy currents. Eddy currents in the metal parts just generates more heat, and that heat is still robbing your power, so it's a bad thing. Past 400 hertz, your eddy currents just go out of control. So they're like, well, we can't do more than 400 hertz in an iron core system. Really can't. It just becomes unmanageable with heat, and efficiencies drop off. You'll notice, in fact, right here, I can show you this. So this is a 5 amp transformer. Most of your switching power supplies nowadays, like for your laptops and the wall warts, especially the wall warts. I don't have any on me. I really don't. But the wall warts that you plug into the wall, they oftentimes switch at between 10 and 20,000 hertz. They use special transformers like this little bitty transformer right here that's a ferrite core. So what they do is they're designed to run at high frequency, so they change the way they're made to handle the higher. So the ferrite core is a higher resistance core, so your eddy currents are lower. It's more difficult for the eddy currents to do anything because your resistance is so much higher than an iron core. So all that kind of stuff. So I will need specialized generators. I say specialized with quotation marks because genuinely all it is the reverse function of a brushless DC motor. If you turn a brushless DC motor, it generates. And they oftentimes run at more than 400 hertz, so they have ferrite cores and stuff. They're made to run high frequency, so high wattage brushless DC motor will do the same in reverse. It will be capable of generating that much power. So specialized is in quotation marks there, but that's the whole point of the engine. Catalyst reaction, which should be more efficient and simpler, just no moving parts, as well as a turbine, which transfers thermal energy into rotational energy significantly more efficient than a piston reciprocating engine does. And again, just one moving part instead of many. And it's high RPM, which I already want high RPM. So that's kind of what we're going for. I just went way out into left field. Anyways, I think I'm going to end this live stream. Yeah, I think we're going to end this live stream here. I think I found where I'm going. I like this direction. the direction this is going in. I actually do like this. It's not what I was planning, but you know what? When you get free stuff, sometimes your plans change. So it's not what I was planning, but I think we're going to go with it. Probably going to cut the coil off the bottom so that I can use these taps right here for vacuum because they already fit the hoses. And then I can use this for fill. I can plug this, and then we'll do a level sensor and temperature sensor down the middle there. And I already have a silicone bushing for that, so bonus. Like Kyle said, I like his idea of having a level indicator on the side. I might still do that. But I don't have a TIG machine. My father does. So if that's going to happen, I'll probably have to take this up to my father's place and get some bungs tigged into the side of this thing. Yep. I think that's where we're going. This is my new boiler. Purify hydrogen peroxide. All right. And we're going to end the live stream. I got to pee like a horse. Oh. Anyways. Thank you very much, everybody, for joining me on here. Kyle and Tom and everybody else. It has been a pleasure. Thank you very much. I'll see you guys in the next one. Oh, before I leave, for the foreseeable future, until I can figure some things out and free up some money, this is how the live stream is going to go. It's what I got. So better than nothing, I guess. Anyways, thank you very much, everybody. I appreciate it. Till next time, have a good night.